Good morning, student. Today we will see what is the actual difference between the glucose and the fructose. Now we know that glucose and fructose both are the isomers because the molecular formula of glucose and fructose is C6H12O6. So the molecular formula is same, but what is the difference between them? So see here, the carbon atoms are same 6. So 1, 2, 3, 4, 5, 6. So numbering from start 1, 2, 3, 4, 5 and 6. So what is difference in that? Now see here aldehyde functional group is there and there are 5 hydroxy groups are present in the glucose. So 1, 2, 3, 4, 5. So that is a not OH, that is a aldehyde functional group, that is a CHO. So but in case of the fructose, molecular formula C6H12O6. So what is the difference here? The carbon atom CH2OH, carbon atom 6CH2OH. The second carbon atom contain, that is a ketonic functional group, that is a C double bond. So third, fourth and fifth, sixth. So these are the same from fourth to sixth is the same. So difference is that the first carbon contain aldehyde functional group and here second carbon contain, that is a ketone group. So glucose is a pentahydroxy 1, 2, 3, 4, 5. So pentahydroxy aldehyde, while ketone is so 1, 2, 3, 4 and 5. So pentahydroxy ketone. So what do you mean by the chiral carbon atom? The chiral means what? The carbon atom attached to 4 different atoms or group of atoms. Four different atoms. So that carbon is called asymmetric carbon atom, or that is called the chiral carbon atom, denoted by the sign asterisk. So that sign is called asterisk sign, which is used to show that is the asymmetric carbon atom. So in that is a glucose, there are the 4. So that is carbon number second, third, fourth and fifth. These 4 carbon atoms are chiral carbon atoms or the asymmetric carbon atom. In the glucose, 2 functional groups are there. So that is a glucose is a bifunctional isomer, that is a alcoholic OH group and aldehydic, that is a dash CHO groups are present. But in case of the fructose, dash OH and that is a keto group, both are present. So these are the bifunctional fructose and glucose are the carbohydrates. Now we will see the ring structure of the glucose. So now we have seen that is a carbon atom 1 to 6. Now see here, this is the aldehyde functional group. You can write that like this: C double bond O dash H. Now hydrogen atom from 5th carbon atom. So that will be moves to this side. That bond goes to break. So O get converted into the OH, and first carbon atom attached to the 5th carbon atom by oxygen. So that linking. So carbon number 1, 2, 3, 4, 5 and 6. So carbon of first carbon atom of glucose attached to the 5th carbon atom of the glucose to form 6-membered ring. So that is the ring structure of the glucose. Now see here, the first carbon of OH and third carbon of OH. So that is a compulsory. It is always to the left. That is compulsory. So the third OH and this OH of C3 and OH of the C1. Now they are opposite to each other. So that structure is called the alpha D glucose, or that is also called the trans. Or now see here, what is changed now here? That OH stays to the left side and H to the right side. Same structure as it is. The C1 first carbon and 5th carbon attached by the O. So there is also formation of the 6-membered ring that ring is called the beta D glucose. Difference is that these are to the same side. The first carbon's OH and this third carbon's OH are to the same side. So that structure is the cis. So there is a formation of the ring structures. So here that is the O. So 6-membered ring. So the which are the left, those are left, they have to write up to the upside, and those are to the right side, they have to write the downside. Now see here, 1. So carbon number 1, carbon number 2, that is the third, fourth one, fifth, and carbon number 6 will be here. So there is a formation of, now see here, H. So to the left side, so it is up, so OH down. In the second, H, OH. Now see, the third carbon atom, OH to the left side, so it will be the up. So H. Fourth, that is the up, here OH. 6 carbon goes to this side and H. And this O, carbon 5 and carbon number 1. So attached by the oxygen atom. So there is a formation of 6-membered ring. Now here the OH of the first carbon atom and OH of the third carbon atom are opposite to each other. So that is formed alpha D glucopyranose. Pyranose, why? Because it is a 6-membered heterocyclic ring is formed. So this is the alpha D glucopyranose. So it is also called the trans. Similarly, there is a formation of the, now see that is, so O. So what will be the change here now? That is change in the third and first OH. So same. CH2OH, 6 carbon atom, H, here H, OH. Now see what will we change? The first carbon atom, H will be the downside and OH will be the upside, which is now in the left side, so it comes to the upside. So that structure. So what is the difference in that? That is the OH of third carbon atom. So write here number of carbon 1, 2, 3, 4. That is the fifth and sixth. So the carbon atom, first carbon atom OH and the compulsory third carbon OH are to the same side. So that structure is called beta D glucopyranose. Now that is cis. That is a ring structure, or they are also called Haworth's projection formula of number. So you will remember that there are 6 carbon atoms in the glucose. The first carbon atom is aldehyde group and 5 pentahydroxy groups are present. So there is a bond between the C1 and C5 takes place or by the oxygen atom. So we have to keep in mind that is the OH of first carbon and the OH of the third carbon opposite to each other. That is the alpha D glucose. So that is a straight. Now that is same structure, but it is a hexagonal ring structure. Similarly here, both are C1 of OH and C1 of the C3 of OH. So they are to the same side. It is a beta D glucopyranose. So they are called the Haworth projection formula of glucoses. Thank you very much for watching this.